October 3rd, 22 minutes into the morning shift, 112 kilometers northeast of Prince George, British Columbia. The boreal forest is so dense here that the sky barely breaks through. Ground temperature -6 Celsius and dropping. A John Deere 959MH tracked harvester is processing a black spruce stem. The harvester head has already gripped the trunk. The delimbing knives, 6 of them, hydraulically actuated, are pulling the tree through at controlled speed, so stripping every branch in under 4 seconds. Then the measuring system counts the log length. The chainsaw bar fires. In a single fluid motion that takes less time than it takes to read this sentence, a tree that has been growing for 60 years becomes a precisely measured log. The harvester head rotates. The boom swings. The machine is already reaching for the next stem. In the next 11 minutes, we are going inside the machines that carry the weight of Canada's forest industry. In the wilderness, in the cold, and in conditions that would stop most equipment dead. The harvesters, the feller bunchers, the forwarders, and the people who understand what it actually takes to move timber through the Canadian boreal. If you enjoy watching real heavy machinery in action, bulldozers, excavators, and the machines that build the world around us, hit that like button. And if machines like these fascinate you as much as they fascinate us, consider subscribing to the channel. But we also want to hear from you. Have you ever worked around heavy machinery? Operated equipment like this? Seen machines like these on a construction site? Tell us in the comments. Many of the best stories in this community come from the people who have actually lived these moments. And now back to the story. But to understand how this operation unfolded, we have to go back. Canada sits on one of the largest forest reserves in the world. Approximately 362 million hectares of forested land. About 9% of the world's total forested area and 25% of the world's boreal forest. In 2022, Canada's forest sector contributed $33.4 billion to national GDP and employed approximately 212,660 people directly. Canada is the second largest exporter of wood products on the planet, holding around 12% of global market share. The boreal forest, that vast belt of spruce, pine, fir, and poplar that stretches from Newfoundland across northern Ontario and Quebec, through Manitoba, Saskatchewan, Alberta, and into British Columbia, is where the industrial harvest happens at scale. It is remote, dense, cold, and almost entirely inaccessible, except through networks of logging roads built and maintained season by season. 50 years ago, harvesting timber in these forests was an intensely manual, labor-heavy operation. Chainsaw crews felled trees by hand. Horses and early rubber-tired skidders pulled logs to roadside. The work was dangerous and slow. The shift to mechanized cut-to-length harvesting, using tracked harvesters and forwarders, changed the industry fundamentally. The cut-to-length system means the harvester fells, delimbs, and bucks each tree into precise log lengths at the stump. The forwarder then loads those logs and carries them, fully supported on a bunk, not dragged, to the roadside landing. No chainsaw crews at the stump, no dragging damage to residual stands, no soil disturbance beyond the machine's own footprint. The tracked harvester at the center of this system is a purpose-built machine, not an excavator, not a modified construction crane. A forestry machine designed from its undercarriage upward for one specific task, moving through dense boreal forest, gripping and processing trees one after another, with the precision of a measuring device and the power of a heavy industrial machine. The most capable machines doing that work carry badges from John Deere, Tigercat, Komatsu, and Ponce. The John Deere 959MH is the largest tracked harvester in John Deere's current forestry lineup, and one of the most capable purpose-built tree processing machines working the Canadian boreal today. It runs on a John Deere engine producing 246 kilowatts, 330 horsepower, at 1,900 revolutions per minute. The maximum boom reach extends to 10.34 meters, or just over 33 feet. This reach determines the machine's working corridor, how wide a strip of forest the machine can process without repositioning its undercarriage. Every meter of additional boom reach translates directly into fewer track moves per hectare, which means less ground disturbance and higher production. The M-Series undercarriage is purpose-built for forestry. The track frames are shaped to deflect debris, branches, root balls, rocks, while providing the stability and tractive effort needed to traverse slopes, deep snow, and soft boreal muskeg. Tractive effort on the 959MH reaches 373 kilonewtons. The leveling system tilts the entire upper structure up to 26 degrees forward, keeping the harvester head properly aligned with steep terrain even when the machine itself is on a significant slope. The harvester head, the rotating, clamping, measuring, delimbing, and sawing device mounted at the end of the boom, is the heart of the system. A modern forestry head like the Waratah T625C or John Deere H754 uses 6 hydraulic delimbing knives, high-speed feed rollers, and a chainsaw bar driven by a dedicated hydraulic motor. The measuring wheel counts log length precisely. The saw fires at the exact preset length. The head rotates to lay the log perpendicular to the machine's direction of travel, positioning it for the forwarder. The Timbermatic system in the cab monitors every parameter of the harvesting operation. Individual tree volumes, total shift production, fuel consumption per cubic meter, saw bar performance, and head component status in real time. The machine processes data as fast as it processes trees. The tracked harvester is not always the first machine in the cut block. In operations targeting large-diameter softwood stands, black spruce, jack pine, and lodgepole pine, at their merchantable maturity, the feller buncher often takes the lead. A feller buncher is not a harvester. It does not process the tree. It cuts and accumulates, felling trees one after another, holding them in the head until a bundle is formed, then laying the bundle down for the processor or harvester to work through. The Tiger Cat 855E is one of the dominant feller bunchers working Canadian operations, manufactured by Tiger Cat Industries, a company based in Brantford, Ontario, that has built its reputation entirely within the forestry equipment sector since 1992. The 855E runs on a Tiger Cat FPTN 67 engine, a 6.7-liter turbocharged diesel, meeting Tier 4 final emission standards. The machine can be equipped with a range of felling heads, bunching saw heads for accumulating multiple small-diameter stems, single-post disc saw heads like the Tiger Cat 5702 for larger trees, or the 5185 fixed felling saw for high-value timber and shovel logging applications. The 855E's ER boom, extended reach technology, is a defining design feature. The ER system allows the operator to extend and retract the boom on a near horizontal plane using a single joystick axis. This eliminates the complex multi-axis coordination that a conventional excavator boom requires and dramatically reduces operator fatigue during high-cycle production work. In dense boreal softwood stands, a skilled 855E operator working at pace can fell and accumulate more than 1,000 stems per shift, every stem positioned precisely for the machines that follow. The harvester processes the tree, but the log still has to get from the stump to the road. That is the forwarder's job. A forwarder is an articulated machine. Its front and rear frames connect through a central pivot, with a hydraulic grapple crane and a rear bunk platform designed to carry a full load of sorted logs. In the Canadian Boreal, purpose-built machines like the John Deere 1210G or the Tiger Cat 1185 forwarder are the workhorses of this stage. The John Deere 1210G forwarder carries a payload of up to 18,000 kilograms of timber per load. Its crane reaches up to 9 meters. The articulated steering allows it to navigate through stands with minimal damage to residual trees, bending through gaps that a rigid frame machine could not access. The extraction pattern matters as much as the machine. In a well-planned cut block, the harvester creates machine trails at defined spacing, typically 20 meters apart, and the forwarder works from those trails, picking up log bundles without ever leaving the planned extraction corridor. This strip road system is the difference between a logging operation that destroys its own working ground and one that can operate the same stand management area again in a future rotation. In deep boreal snow, and northern Ontario and British Columbia see winter conditions where snowpack exceeds 1.5 meters, the forwarder's wide flotation tracks and high ground clearance become critical. The machine must be able to reach logs that are half buried in frozen conditions and extract them without getting stuck itself. The load leaves the forest sorted, measured and ready for the sawmill, every log carrying exactly the information the mill needs to process it. The machines carry the technology, but the forest does not cooperate with technology. Operating a tracked harvester or feller buncher in the Canadian Boreal is a long-cycle, high-attention task that demands a type of spatial reasoning few other equipment roles require. The operator must simultaneously manage boom position, head orientation, steering, track tension on uneven terrain, and the harvesting system parameters, all while reading a stand of trees for the next sequence of cuts. In the northern Ontario and British Columbia interior, winter operations run through conditions that frequently drop to -35°C. Hydraulic fluid at those temperatures behaves differently. Machine warm-up procedures in deep cold take 20 minutes or more before productive operation can begin. Swing brakes, boom pivot pins, and track drive motors all carry cold weather performance risk. The terrain itself is the greatest challenge. A boreal muskeg, the water-saturated peat ground that underlies much of the northern forest, can support a machine one day and swallow it the next, depending on freeze depth and moisture conditions. Experienced operators learn to read the ground the way a ship's captain reads the sea. Ice patterns, drainage flow, the way standing water collects. Modern harvesters carry terrain management data through their operator systems, but experienced operators carry it in their knowledge of the specific site. A harvest block in the Canadian Boreal forest can span several hundred hectares and take weeks to complete. During that time, the operator becomes intimately familiar with every drainage swale, every soft corner, every ridge line that will hold a loaded forwarder and every one that will not. That knowledge is not in any manual. It accumulates shift by shift, season by season, through years in the same forest. By the time this harvester's shift ends, the cut block is measurably smaller. The logs at the landing are sorted, measured, and queued for transport. Somewhere, a log truck is already rolling toward the nearest sawmill. This is the immediate result. But the broader consequence of Canada's mechanized forestry operation reaches much further. Canada's 212,660 forest sector workers, most of them in rural and remote communities where the forest industry is the economic backbone, represent a social infrastructure that is invisible to most Canadians. The machines they operate and the timber those machines produce underpin housing, pulp and paper, engineered wood products, and biomass energy supply chains that reach around the world. The long-term impact of how this harvest is conducted matters enormously. Canada harvests approximately 0.2% of its forested land annually, and by law, every harvested area must be regenerated. In 2020 alone, 603 million seedlings were planted across 417,000 hectares of provincial forest land. The harvest and the renewal are managed as a single system. The modern relevance of these machines extends to a question the industry is now actively working through. How do you further reduce the environmental footprint of the harvest itself? Hybrid and electric forestry equipment is in development and early deployment. GPS-integrated cut planning tools are reducing machine travel per cubic meter of wood produced. Precision forestry, the principle that the machine should touch only what it intends to process, is the direction the technology is moving. The forest is not a static resource, and the machines that work it are not static either. If this story meant something to you, consider subscribing to Machine Geek Canada. This channel exists because people who appreciate these machines keep coming back and sharing their experiences. And if you've ever worked around heavy equipment, bulldozers, excavators, demolition machines, tell us your story in the comments. What machine did you operate? Where did you work? What was the toughest job you ever faced? Many of the most powerful stories come directly from the people who have lived them.